20% greater than her income in 2003. Ratio of her income in 2004 to 2003. I don't even remember that one.
Well, there's a couple ways you can do this. First of all, if her ratio is 1.2 divided by 1, that's 6 to 5.
How did you get that? Oh, because of 20% greater. Got it.
Okay, let's do it an easier way. Pick some numbers. Give me an income for, they don't give us the income, so we can make up anything we want. Give me a nice, reasonable income for 2003.
50,000.
Okay, I would have picked 10,000. Here's why. What is her income in 2004?
It's 20% greater than 2003. Is the 10,000 her 2003 income?
Uh-huh.
So 20% of 10,000 would be 2,000, right? So 12,000?
Yes, that's why I would have picked 10,000 instead of 50,000.
Okay.
You picked 50,000. We could have still done the problem. It's just the math is harder. In other words, if I got to figure out what 20% of this is and add it, I get that. Well, yeah, we can still do it. It's just when you're picking numbers, pick the numbers that make the math the easiest.
Okay.
Now, what is the ratio of 2004 to 2003?
12,000 to 10,000, so that would be 6 to 5?
Yeah, let's make it 12 to 10. Eliminate all those extra zeros. That is 6 to 5. Same thing you get if you pick 50,000, but pick numbers where the math's going to be easier to do.
Okay.
All right, and scroll down to, oh, I guess I'm already scrolled down. Now, this problem has a giant flag right in the middle of it. And that flag is that they have variables in the problem, n, and every answer has a variable in it.
Aha.
You should notice that instantly. What does that allow you to do?
Put in numbers?
Exactly. Make up numbers for n. In other words, clearly n is not a specific number. It's anything. When you have variables in the problem and you have the same variables in all the answers, it means you can make up any variable you want. Okay? And what we see is that we're going to need 4/5 of that. So make up a nice round perfect number for n.
Perfect 10.
We're going to have to multiply it by 4n over 5. All right, that's fine. I don't have any problem with 10.
Would you have picked 2?
I would have picked some multiple of 5. That's fine. You picked 10. That is a multiple of 5. The reason is because I got to multiply that by 4/5. Okay. So how much does he spend each week?
He spends for $8.
Okay, so he spends 8
And saves 2.
To save $500, how long is it going to take him?
1,000 weeks.
No, you're saving $2 a week. You're going to save it in 500 divided by 2.
Oh, 250 weeks.
250 weeks. So that is the answer when n equals 10.
Okay.
Now, so all we have to do is go through each of these questions, substituting 10 for n, until we come up with the answer 250.
Okay.
Does A work?
No.
Does B work?
Yes.
Okay. With this method, you kind of have to check all of them, because sometimes you can get 2 answers that work. Then you got to go back and pick a different n. But real quickly, does C work?
No.
Does D work?
No.
Does E work?
No.
We're done. We got our answer. Now, I could have picked any n that I wanted. The key is to pick an n that lets you do the math easily.
Okay.
Okay? And it's almost magical that it's very difficult to solve this algebraically. It just is. For anybody, I think. But for some reason, when you pick an n, you get this very easily, right? That was no problem. Once you picked an n, you were able to figure out how many weeks it would take him to save $500. So the advantage of picking numbers and testing the results is that the mind always knows how to do this math. If you pick an n, the mind doesn't always know how to set this algebraic equation up. We can talk about it for a moment. You're going to save 1/5 n per week, right?
Right.
And in order to save a total of $500, you got to divide that into $500. In other words, if you want to save $500 and you're saving $2 a week, you divide 500 by 2. If you want to save $500 and you're saving $50 a week, you divide 500 by 50. Well, we're saving 1/5 n per week, and if I do that math, I get 2,500 divided by n. So that is the algebraic way to do it. But notice how much tougher it was.
It was.
A lot tougher. Because first of all, I got to handle that. In other words, I got to know whether I'm dividing or am I multiplying and all of that stuff. When I just did it, I wasn't even positive about that. The only reason I finally became positive was because I realized that's the same answer as what we got when we picked numbers. So picking numbers is often the most accurate way to do it. Even if you can figure out the algebraic way of setting it up, you're more likely to make a mistake than picking numbers. If my life depended on getting 16 correctly, I would pick numbers. I would not do it algebraically.
Okay.
Remember what you look for when you're picking, when you're going to use the picking numbers technique. You're looking for a variable or variables. Sometimes they'll have 3 variables in the problem, And all 5 answers will have 3 variables. Well, that's almost a guaranteed pick numbers problem.
Okay.
This one only had 1 variable in the problem and 1 variable in every answer. That still means that we can pick anything we want for that variable. They're not giving us that variable.
Uh-huh.
All right. Let's go on to the next page. I'm not certain we haven't covered some of these. These 2 problems refer to some sort of graph, and I don't know what page the graph is on.
Oh, no.
Well, because they're out of order, and I'm kind of going in order.
Okay, so
What they're showing, what they're asking about here is based on some other information, both 8
right, I think,
and 19. So
yeah.
we need the graph that came before that. I don't know how to find it, so let's not worry about it at the moment. Maybe we'll come across it.
Okay.
Just keep going, and if we run out of problems, we'll try to figure out what that graph was. Now,
Okay.
this one. I saw some print right above this. Which I can no longer see. Are you looking at this by chance in a book?
I can find it.
Well, you don't necessarily need to. This may be all we need. I see a solid line above it. I think this 2 and x that I'm looking at here is the previous problem. I don't think it has anything to do with this problem. No, it doesn't. That was problem 3, this problem 4. We're fine.
I'm furiously getting the next set of problems ready for you.
Okay. We're going to need them soon. I'm not sure how soon. Let me look at this problem. This looks like a toughie. Any ideas on this one?
Median income.
Median means middle.
3,000 higher than the median after 6 months of graduation. Okay. The 75th percentile of the incomes of the group C. Oh, do you have to do the standard deviation with this?
Well, not really. Not really. My first reaction to this is a hard problem, but my first reaction was, can we lay out a couple of incomes to match their conditions, and can we tell whether the 75th percentile is higher or not?
Aha.
Well, let me lay out 5 incomes. For each group. This will be C, that group. We know that the median income, so we'll say $1, $3, $6,000, $12,000, $13,000. Agreed, the median income is $6,000.
Yes.
And we'll lay out a group D. And the only thing we have to know is that that median income is only 3,000. And we'll still lay out those. Only up here, let's make it 100,000 and 120,000. Do we satisfy the conditions of the problem?
Yes.
Can we tell which one has the highest 75th percentile? From this data, which one would you think?
I'm guessing group D.
Yeah. But what if I change the conditions? Absolutely. In other words, the 75th percentile is going to come by comparing these two. That's the 80th percentile, close enough, okay? But what if I change this, instead of being 100,000, I make it 4,000, and this 5,000. Now, which 75th percentile is bigger?
C.
Therefore, the answer is?
You can't tell. So
those problems where you're trying to basically prove D from the start. In other words, when you look at this problem, either it's going to be A or D. It's never going to be B or C.
It's never going to be B or C because why?
Either the group C are going to win, right? Their median income is $3,000 higher.
Right, because it can't be equal.
So the immediate reaction would be group C is going to have the heavier 75th percentile, the higher.
Right.
So the first thing I try to do is to prove that.
Right.
And I did it. When I put 100,000 on there and 200,000 on there, I disproved it. And
okay.
The numbers that I just put down for C and D, D is the higher 75th percentile.
Okay.
And that's unexpected. You would expect C to be higher, merely because their median was higher.
Right.
Well, so the moment I disprove it, I'm actually ready to go on to the next question. In other words, I don't really have to come up with the second condition that proves that C is the higher. Once I've realized that I can put a low median and as big a numbers as I want to the right of that, I can make this 1 million and this 2 million. In other words, the median does not really control the 75th percentile.
Okay.
Perhaps I'd have been better off if I hadn't put 5 entries, if I'd only put 3. For example, if I'd have put this. The problem with, by 3 I meant 4. The problem with putting 4 is then you have to take an average between 3 and 4. The advantage of putting 4 is that you know the 75th percentile immediately because it's the third number. But the same concept can be gathered from that. By changing the 4th and 5th number of each row to whatever I want, I can tell that I'm affecting the 75th percentile drastically.
Right.
So I can make either one bigger. And that means you can't tell.
Okay.
The other way I meant maybe to do it would be, let's say that was C, and that would give you a median of 4, and C has to be twice D, so my median has to be 2, so I could do 1, 1, 3, 10, let me do, ooh, now that I do it this way, now I'm not so sure. Hold on, let me look at this a second.
Well, the book says it is D.
Yeah, my intuition says D all along. So this exercise might be pointless. In other words, I'm trying to do it a little more accurate, because if I can do it with 4 numbers, I know the 75th percentile is that number and that number. Whereas when I use 5 numbers, intuitively I know that the 75 percentile, if this is 100,000 and 200,000, the 75 percentile is going to be bigger in D. Whereas if I try to come up with exactly 4 numbers that match it, it turns out to actually be harder to do. I'm trying to figure out what 4 numbers give a median that's 2 times bigger, and yet a third number that is either bigger or less. And it's harder to actually figure out doing it this way down here. So perhaps that is the best way to do it, where I came up with 5 numbers, because the median is always the third number.
Right.
When you have 4 numbers, the median is the average between numbers 2 and 4. And,
right.
Or I'm sorry, between 2 and 3. And then you're comparing 3. Well, as you can see from my example, it's actually more difficult to do, and I haven't been able to do it. So my first technique turns out to be the better way to look at it. Let's see, this was 101. I got one more page.
Okay.
That maybe we've done, maybe we haven't. We've done this one. You remember what 7 is?
Oh gosh.
How would we do 7?
Quantity D we said was big.
Try not to memorize what we did before. What I'd like you to do with 7 is work out the logic from the get-go.
Then between 1 and 199, it's bigger than 2. If it were equal, it would be 2 to 200. But it's 2 to 198.
Example to prove your point. We don't have to use the numbers 1 to 199. I don't have to add up all those odd numbers. I can use the numbers 1, 3, and 5. Now, what equivalent numbers would be B?
2, 4, and 6.
Actually, just 2 and 4.
Oh.
Notice that 198 has to be less than 199. That means this last number has to be less than 5.
Okay.
In other words, this duplicates the problem they gave us. This number is 1 higher than their first number. This number is 1 less than their last number.
Aha.
If I add these up, I get 9. If I add those up, I get 6. Even if I used 1, 3, 5, 7, what would be the numbers for quantity B?
for quantity B,
if I let the numbers be 1, 3, 5, and 7 for A,
it'd be 2, 4, and 6, right?
correct. Which one is bigger?
Group A.
Always. Bigger there, bigger there. It's going to be bigger even if we go from 1 to 99.
Right.
So problems like this, where you can't actually do the full counting, in other words, there's no way I have enough time to list all the odd numbers between 1 and 199. But I do have the ability to do it for the same condition. In other words, 1, 3, and 5, which gives you 2 and 4 over here. Then I can solve the problem by working with those small numbers that I can come up with the answer real quickly. And realizing that it doesn't matter what the ending number is, as long as this one starts at 1 and goes odd numbers up to whatever number, and this one starts at 2 and goes even numbers up to 1 less than this number. That's what you have to realize. Okay. We did 8 also. 8's actually relatively easy. First of all, I can solve that by doing what? What's my next step when I look at that?
S is 32 and T is 2? Is that what you're saying?
No. What's the relationship between 32 and 2? How could you express 32 as a power of 2?
It's 2 to the 5th.
Okay. So if I do that, in other words, the first thing I want to notice about this problem is that 32 is a power of 2.
I was one.
It's not
Sorry,
6
I didn't.
times 2. It's 2 to the 5th. In other words, because I'm looking at exponents, I want the exponential relationship.
Right.
Okay, now what's the left side become? Once I convert 32 to 2 to the 5th, what do I have? What's the rule of exponents?
So 32 would be, the first S would be 1 over 5, right?
Now, hold on. Let's do this one step at a time. Go from this step to the next step. What is 2 to the 5th to the S power? You have to know the rules of exponents.
Well, you multiply the 5th times S, so it's got to be 1, right?
No, so it's that. It's 2 to the 5S equals 2 to the T. You with me? You know exactly what I'm doing? Well, when I have one base to one exponent equals the same base to another exponent, then it's proper for me to say that 5S equals T. Only then.
Okay, right.
Only then can I do it. Well, they want S over T, so I'm going to divide both sides by T. So I get 5S over T equals 1. Now I'm going to divide both sides by 5. So I get S over T equals 1/5. There's my solution.
So they're equal.
And they're equal. But it requires you to go through each of these steps. And the very first step really kind of depends on you recognizing that 32, the first thing you should say to yourself when you see this problem is we're dealing with exponentials. When you are, because both variables are in the exponent. My S is an exponent and my T is an exponent. That's exponential stuff.
Right.
And when you see a problem about exponentials and you see two numbers like 2 and 32, then you want to start saying, well, how can I define 32 as a power of 2? In other words, how can I define 32 as an exponential? And it's 2 to the 5th. And once you make that connection, that you can write 32 as 2 to the 5th, the rest of the problem becomes easy.
Aha. So I sent you the email with the other problems.
Okay. Let's see if I can get it here. Okay, good. This is a PDF. That actually probably works better for me.
That way I know all the questions are in order.
Yeah, exactly. And also, for me, it really works better because if I'm ever doing this again, I'll know what I'm looking at. All these image files, I kind of have to open them to see what I'm looking at. So, all right, let's have a look at this. Yeah, I remember when you first asked me, I said send them all as pictures, and I was wrong. It actually works better if you send it as a PDF file.
So this might look fuzzier because I took these pictures really quickly.
Well, I have not. Oh, there we go. Said I guess I haven't figured out how to work this program yet. As long as I can read them, that's all that really matters, whether they're fuzzy or not. Yeah, I think we can read this. What's our first step going to be?
Draw the picture.
Absolutely. So it's inscribed in a square, so I'm going to draw the square first, and I'm going to put a circle inside of it.
So the diameter we know is 5.
Yes. However, when you're dealing with circles, diameter is not the most important thing. Radius is. All of your formulas are in terms of radius, and I mean all of them. There's one formula that's in terms of diameter, but it shouldn't be, and that is the circumference. What is the?
But it's asking about the circumference.
What is circumference?
Quantity A is the circumference of the circle.
No, but what's the formula for circumference of a circle?
Oh, 2 pi r.
Okay. Notice that you didn't tell me pi times d, which is actually another definition of it, but one that I try to suppress. I don't like talking about diameter. If somebody tells me diameter, I immediately figure out the radius and go from there. Because circumference is in terms of radius, area is in terms of radius, volume of a sphere is in terms of radius. So radius is really the key, not diameter. Even though you could just as easily say circumference is pi d. It's just not what I use.
Okay.
Okay. So what's the radius in this case?
2.5.
And 2 times 2.5 is going to be 5, so the circumference ends up being 5 pi. Which is bigger, quantity A or quantity B?
So I don't know how to compare pi to a
So we're comparing the circumference of the circle, which is 5 pi.
Right.
Put a little circle there as a as opposed to the circumference of the square. So the circumference of the circle is definitely 5 pi.
Yes, but what I'm saying, I don't know how to compare 5 pi to 15.
Well, what's pi equal to?
3.14. Okay, so then the circumference is more.
In other words, you don't really need a calculator. The moment you realize pi is greater than 3, problem's over.
Okay. Understood.
And would have worked just as easily if I would have used a formula that said pi d. You'd have substituted 5 for d. You'd have still gotten 5 pi. Actually looks like it would have been a step easier. I still don't like using it. I do not like anything in terms of diameter. They'll give you a lot of problems where they give you the diameter, and when they do, the very first thing I do is take half of it and use all the formulas that use radius.
Okay.
Only because most of your formulas do use radius. They don't use diameter. Okay, hold on a second. Okay. Very first thing we need to figure out, or what's the first thing you notice when you look at this problem? The very first thing you know for sure.
It's all variables.
Well, what about u and v? What do you know about u and v?
Oh, they equal 0.
No, one of them has to be 0.
Right.
Absolutely, okay. One of them has to be 0. We don't know which one. It could be u, it could be v.
Okay.
So if u is equal to 0, then v is 14. Right? If v is equal to 0, then u is 7. So in this case, the second case, u is bigger. In the first case, u is smaller.
So the answer is D.
We're done with it instantly. The key to this problem is knowing that when you have two things multiplied together that are equal to 0, one of them has to be 0. If I have u times v times x equals 0, one of those three has to be 0.
Okay.
You cannot find two numbers that multiply to 0. The only answer is one of them has to be 0. One or both. It could be both, but at least one has to be 0.
Got it.
Ooh, hold on a second. I must have missed something here. I must have gone down to, yeah. No. Ah.
Which one?
What are we doing? We're doing number 3. Okay.
Yeah, I had to write those numbers in because I didn't know if you could have seen them.
I got you. I got you now. Okay. So which number is bigger? 950 to the 2,000th power or 10 to the 6,000th power? And the picture of the calculator you sent me does not allow you to do this number, this calculation. Correct?
I'm sorry, the what?
You sent me a picture of the calculator they allow you to use when you're taking the test.
Right. No,
it does not allow you to take numbers to exponents. It might allow you to square something, but that's about it.
Correct.
Okay. So we have to figure out, intuitively, which one would you think?
I would say quantity B.
See, I would say quantity A. Merely because it's such a bigger base. However, I'm not sure at all. So, what can we do? 10 to the 6,000 power is 1 with 6,000 zeros behind it. That is an enormous number. But so is the one on the left.
It is.
So, what if we did this? 10 to the 2,000th times 95 to the 2,000th. That's a true statement. You see why? We had another problem that was kind of like this, where you had to break up one of the numbers into the same base as is over here. It was that ridiculous problem that had something about 2 or 5 and 10 in the denominator, and you had to express it as one of the others.
Right.
So
if you look at it that way, then quantity A is bigger.
Not necessarily. No, because this is 10 to the 2,000th. This is 10 to the 6,000th.
No, but based on the equation that you just wrote.
Still doesn't tell me quantity A is bigger. Because I don't know that, 10 to the 2,000th only has 2,000 zeros behind it. This has 6,000. In other words, I haven't written it in exactly the way. If I could have written this 10 to the 6,000th, yes, then quantity A is definitely bigger. But I was not. So
okay, maybe I didn't explain myself very well.
I just figured out how to figure it out. And it's not obvious at all. Let me do this. This is kind of, there may be a better way to do this, but this works.
Ha!
Notice that what I've written here is bigger than that. Correct?
What do you mean?
Well, because 95 is not 10 times 10. 10 times 10 is 100.
Right.
So 10 to the 2,000th times 10 to the 2,000th times 10 to the 2,000th has to be bigger than that. That is only, here, let me write it a little differently. I can explain this better. I love these problems, actually. They're very clever. If I were going to split this up, I would say 10 to the 2,000 times 10 to the 2,000 times 9.5 to the 2,000. With me?
Okay.
Now, which is bigger? What I just wrote right here, or this?
The one on the bottom.
And the one on the bottom is 10 to the 6,000.
Right.
So quantity B is bigger.
Aha.
And this is a really difficult concept, I think. The whole idea, well, I don't even know what the idea is. This solution came to me in the middle of trying to solve it. but this is definitely the best way to go. Break it up into that, and then realize that 10, and realize that this is bigger than that, and that this is equal to that.
Right.
So you have to realize that this is bigger than that. Tough problem. This definitely would be one of the tougher ones. And despite the fact that it's number 1. Or no, it's number 3. Even still. Usually the tougher ones don't start until you get to the bigger numbers. All right, let's see. We got 10 minutes here. Let's have a look at this one. Wow. How come these are so much tougher? Usually these quantity comparisons are pretty easy on the low numbers. I'm not getting easy when I look at them.
You can read that?
I'm getting medium and hard. Okay.
So we have to do the Venn diagram?
Well, yeah, I suppose, yeah, that's a good way to approach it. Hold on a second. So we got a set of numbers with 40 integers. We got a set of numbers that 150 integers. There's 20 in both. So what's the rest of this area on the left?
So that would be 20.
How about the right?
That would be 130.
Okay. So the number of integers, so the total number of integers that are in set A or set B or both versus 170.
That would be, so if it's just set A, quantity B is bigger. If it's just set B, quantity B is still bigger. But if it's both set A and B, oh, but that's just the 20, right?
The total number of integers that are in set A, which is 40, or set B, which is 150, or both, which is 170.
Right.
So set A, the answers to this are 40, 150, or both 170. The answer to that is 170. So what do you think the answer is?
D. Because at least 2 of the answers are less than quantity B and 1 is equal.
You're absolutely right. You're right. At first I was going to say C. But then I realized that the ORs mean that you have to consider that answer, and that answer. Had this said the maximum of those 3 things, then the answer would have been C.
So wait a minute. The answer in the book does say it's choice C.
Yeah, I had to look at this for a little bit, and your explanation actually made more sense to me. In other words, because they say the total number of integers that are in set A, well, that's 40, or set B, that's 150, or both, that's 170. So quantity A, it seems to me, could be any of these 3 numbers. They didn't say the maximum, which would have meant that the answer was 170. I know. I'm in your camp. I think the answer should be D.
So they say the total number of integers in set A or set B or both is equal to the number in set A plus the number in set B minus the number in both sets.
Which is 170.
Oh.
No, I don't agree, actually. Hold on a second. I need to close my door here. No, the fact that the wording they use is what gives me trouble. In other words, when you look at those words on the left, it says the total number of integers in set A or the total number of integers in set B or both. There's three possible answers. When they put ors in there are three possible answers to quantity A.
So they messed up.
I think so. And I'm pretty sure. Like I said, if they really wanted the answer to be C, they should have said the max. The max of the total number of integers that are in set A or set B or both. And then that would have meant 170. But the way they've worded it, it seems like there's three possible answers on the left side. I mean, this almost would be more of a verbal problem than a math problem. The way they've looked at it, I don't know.
Yeah.
I mean, they're not perfect either. They can certainly make mistakes, and that seems like it's one to me. You got time for one more?
Okay.
Do this one.
X is a negative number. So would quantity A be 1/2?
Well, no. It's just you don't know what X is. It does, because it's a negative integer doesn't mean it's -1.
Right.
However, what we want to do is try various combinations of negative integers. Okay. Well, there's not a whole lot of negative integers. Let's let x equal, how about -2, and then we'll try an x equal to -10.
Okay.
Okay. So what is 2 to the -2 compared to 3 to the -2 plus 1? What's this equal to?
So 2 to the -2, would that be -4?
No, it would be 1 over 2 squared, which is 1/4. Remember that? Remember how to handle.
I do remember that. That's why I said 1/2.
Well, it's 1/2 squared.
Okay.
What it is.
1/2
squared. That's how you interpret negative integers. So what's this one?
So the -2 plus 1 would be -1. So that would be, that would be 1/3.
Perfect. Which one's bigger?
1/3.
Okay. Now let's try x to the -10th. So this becomes 1/2 to the 10th.
Holy cow.
Well,
I haven't memorized that part.
And this becomes 3 to the -9th, which is 1/3 to the 9th. And now we got to compare those. I don't even know which is bigger, 2 to the 10th or 3 to the 9th. I'm not sure how to figure that out. Which one would you think would be bigger?
I would think 2 to the 10th, but I have nothing to back that up.
Yeah, see, I would think 3 to the 9th. Here's why. 2 to the 3rd is 8, 2 to the 4th is 16, 2 to the 5th is 32, 3 to the third is 27. 3 to the fourth is 81.
2 to the 10th is 1,048,576.
Could you have gotten that without with the calculator you're going to use?
No.
So don't do that. In other words, that's not going to help using your calculator. It'll help solve this problem, but that's not the point here. The point is, how would you solve this problem when you're taking the test? So just looking at it, notice what happens if I look at a couple of powers. The 3 to the third is bigger than 2 to the fourth.
Oh, wow.
And 3 to the fourth is bigger than 2 to the fifth. And not only that, it keeps getting bigger and bigger and bigger. 3 to the fifth is bigger than 2 to the sixth, which is 64. Not only is it bigger, but the ratio is getting bigger. That was 1.5 times bigger. That was more than 2 times bigger. This is almost 4 times bigger. So there's no question that when you get to 3 to the 9th, that is a bigger number than 2 to the 10th. Probably by a lot.
B is bigger.
No. Notice that we're looking at denominators. 1 over 2 to the 10th versus 1 over 3 to the 9th.
Oh, so A is bigger.
Correct. In other words, the bigger denominator is a smaller number. So A is bigger than B. The opposite of what we found when we used an x of 2. X of 2, B was definitely bigger than A. So what's the answer?
A.
D.
Oh, wait.
Because we found both cases. We found a case where B was bigger than A, and we found a case down here where that is bigger than that. And you got to be really careful. It's true that 3 to the 9th is bigger than 2 to the 10th, but that makes 1 over 2 to the 10th bigger than 1 over 3 to the 9th. In other words, when you take the reciprocal of a number, the bigger the denominator, the smaller the number.
Right.
So this is a bigger number right here than this. And yet, in this case, B was bigger. So in one case, I got B bigger. In the other case, I got A bigger. That's easy. We're done.
Okay.
And I didn't have to worry about using anything but negative integers. I didn't really need to use something as big as x to the minus 10th. The problem is had I used 3, I'm not sure that would have convinced me. By using a number that's much bigger, or smaller, as the case is, it's actually easier for me to figure out the problem. In other words, I started out with x equal to 2. Oops, I'm sorry. Carolyn, I got to go. I got a 4 o'clock that I'm late for. I got carried away on this problem. That's a good problem. Okay, so we left off on number 5. Talk to you soon.
Okay, great.
Bye-bye.
Okay, thanks. Bye.